Welcome, everybody. Today, we are going to talk about the AL Abacus with multiplication and division. I am going to be your host today. I'm Kathleen, and we're going to, again, talk about multiplication and division using the AL Abacus. I think a lot of you have probably been on one of our webinars before, but let me just run through a quick housekeeping details. The sound is muted, so you do not need to worry about any of your background noise. Just a second, but making sure you can see my screen. Sound is muted, so you don't need to worry about any background noise. And if you have any questions, use the chat box right here. And then you use the chat box, and then you can pose your question that way, and I will answer them. I may not answer them immediately because either I want to finish my thought or maybe your question is something that's going to be addressed just shortly, but I will answer all questions as we go along here today. All right, let's go ahead and get started. I'm going to be pulling today's topics from the RightStart Math program. I'm going to be pulling them from level B and level D. Now, multiplication and division is taught in level C, but I'm just pulling lessons from B and D just for today's topics. And again, similar things are also in level C and E. All right, we're going to start out with introducing multiplication. This is actually taken from level B. So the first thing we want to do is have the child put on 6. Here we have 2 6s. You can see that the total there is 10 and 2 more, 10 with the blue beads and 2 with the yellow beads. You can call this 6 taken 2 times. And as we said, we can see the answer, it's 12. Let's do another one here. Now we have 6 taken 3 times. We can see our answer is 18. We can see the 15 with the blue beads and 3 more with the yellow, totals 18. Here we have 9 taken 3 times. This is a little bit hard to see the answer, so we're going to use something called take and give. So I'm going to take from this bottom line, take a bead from down there, and exchange it or trade it with a bead from the top there. So I'm going to take and give. So I'm going to do 1, 2, 3, trade. And I'm going to do it again here. Oh, and now I very clearly can see my answer is 2, 10, 7, or 27. We can write this as 9 times 3 equals 27. Here we have 8 taken 4 times. We can solve this one a couple different ways. I can see my 10, 2 10s, so that's 20. Here's 12, so 20 and 12 is 32. I could also do it by seeing it as here's 16, 10 and 6 more with the yellow, so 16, and 16 plus 16 is 32. Or if you like to use the take and give, you can do take and give and come up with the same answer of 32. So there's multiple different ways to calculate the answer, to determine the answer. Now, there's a note in this particular lesson that I want to bring to your attention because this is very important. A lot of people look at 6 times 3 and they say, gosh, is that 6 taken 3 times? Or is that 6 groups of 3? Well, this is actually something with Dr. Cotter. She actually researched for about 2 years before she came up with a definitive answer. And this is what she came up with, is 6 plus 3 starts with 6 and we transform it by adding 3. 6 minus 3 is we start with 6 and we transform it by subtracting 3. 6 divided by 3 starts with 6 and we transform it by dividing it into 3 groups or into groups of 3. So therefore, wouldn't it make sense that 6 times 3 starts with 6 and we transform it by duplicating it 3 times? So 6 times 3 is 6 taken 3 times. Any questions so far? All right, let's look at multiples of 2 and 4. This is coming off the level D lessons. Multiples of 2 and 4. We're going to start with the 2's. Here I have 2. We write this as 2 times 1 equals 2. Pretty basic. 2 times 2 is 4. 2 times 3 is 6. 2 times 4. Basically, we end up skip counting by 2's. That's the 2's. Super easy. Now, let's go to the 4's. Here, of course, I have 4 times 1 equals 4. Here we have 4 times 2 equals 8. 4 times 3 is 12. Excuse me, it's 12, but it's a little bit hard to see. So actually what we're going to do is we're going to separate this. We're just going to move these over just a little bit. And now I can see that I actually have 2 times 3 doubled. 2 times 3 is 6. 6 doubled, or 6 plus 6 is 12. Well, now that's a clever way to look at this. So 4 times 3 is 12. 4 times 4, using the same separation, I can say that would be 2 times 4 doubled. So 8 times 2 is 16. Or I could say 8 plus 8 is 16. 4 times 5 is 20, and we keep going. Why do we have these various approaches? Well, it helps the child see the multiplication facts from many different perspectives. So often, multiplication is taught simply rote. And if the child forgets what 4 times 5 is, there's no way to remember it. Whereas with the abacus, we give them different approaches and different ways to look at it. It provides an easy path to the answer, or multiple paths to the answer. It also prepares the child for the multiples of 8. So let's go look at multiples of 8. We're going to start out by putting 8. Of course, this is super easy. 8 times 1 equals 8. Here we have 8 times 2. I can see my answer is 16. Again, by looking at my blue beads, I have 10. My yellow beads, I have 6 more. My answer is 16. 8 times 3, a little bit more complicated, so let's split it so we can see. We can do it a couple different ways. We can look at the blue beads, and I can see I have 15. The yellow beads, there's 9. 15 plus 9 is 24. Or my personal favorite is I do the split. And then I can see I have 4 times 3 doubled. 4 times 3 is 12. 12 plus 12 is 24. 8 times 4 is the same thing as 4 times 4 doubled, which is 32. 8 times 5 is 4 times 5, 20, doubled, which is 40. 8 times 6 is the same thing as 4 times 6 doubled. 8 times 7, 8 times 8, 8 times 9, and 8 times 10. Let's look at our multiples of 10 and 9. Well, 10 is, again, another very easy one. 10 times 1, 10 times 2, 10 times 3. This one doesn't take a whole lot to figure out. But the 9s, now that's a little bit different. 9 times 1 equals 9. 9 times 2, I can see again, I've got the 10. And the yellow beads is 8. So my answer is 18. 9 times 3. Well, this one's a little bit more difficult. So I could use the take and give like we did earlier and come up with 2, 10, 7, or 27. Or we could do it this way. How about if I do 9 times 3 and then I say, how many beads are on these 3 rows all together is 30 minus 3 is 27. Let's do that one again. That second one is my favorite. 9 times 4 would be the same thing as 40 minus 4, which is 36. 9 times 5 is 50 minus 5, 45. 9 times 6 is 60 minus 6, 54. All right, let's look at the multiples of 3. Here's multiples of 3. So here we have 3. 3 times 1 is 3. 3 times 2. Now, I'm not going to push that all together here because I want to see that I've got two groups of 3. But if I just look at this number, I have how many altogether? I have 6. 2 times 3 is 6. 3 times 3 is 9. Here's 3 times 4 is 12. Again, I can see that I have 10 and 2 more. I have 12. 3, 4 times is 12. 3 times 5 is 15. 3 times 6, 3 times 7. Again, I can see that I have 2, 10, 20, and 1 more, 21. 3 times 7 is 21. 3 times 8, 24. 3 times 9, and 3 times 10. And of course, that makes a beautiful pattern. So why do we use the AL abacus and the patterns? Our brains are wired to think in pictures. The abacus provides a mental image for future use. And this works very well with children with learning challenges because they are even more visual than a child without learning challenges. This is why we want to use the AL abacus and seeing those patterns. Let's look at multiples of 6. 6 times 3, I can do this one of two ways. I can see that I have 15 and 3 more, which would be 18, or I can split it again and say it's 3 times 3 doubled, which would be 18. 6 times 7. I can see that that's the same thing as 3 times 7, which is 21, doubled, 42. I actually use this a lot personally. This helps me with my 6s and 8s by using these doubles. Multiples of 7. Here what we're going to do is we're going to use a different strategies with these because obviously we can't split these and come up with doubles. So what we're going to do with these is look more at the visual images. 7 times 1 is 7. 7 times 2, again I can see I have 14, 10 and 4 more, 14. 7 times 3, back up here, I'm sorry, 7 times 3, I can see I have 15 and 6 more is 21. 7 times 4, I have 10, 2 10, so 20, 8. 7 times 5, this is 25, and 10 more is 35. So what happens is the children get this image in their mind's eye. So somebody says 7 times 5, and they see this. Oh, that's right, it was 35. Here's 7 times 7, 25, 35, 45, and 4 more makes 49. So with the 7s, we're more using the images. This next lesson here, the area on the multiplication table, for some reason, this totally intrigued me. As I mentioned, I was taught kind of a drill and kill method, and so I just thought that these were numbers. I never understood why the multiplication worked. To me, it just kind of did. I had no idea why. So when I actually saw this, for me, this was very intriguing. Let's look at area on the multiplication table. If I take 6 times 4, so I take 6, 4 times, my answer is 24. It's the same thing as 4 times 6. So if I take 4 6 times, it's also 24. So we're looking at area and seeing how the two are related. Let's do another one here. 8 times 7. So I have 8 7 times is 56. Here's 7 times 8, which is also 56. All right, let's look at division. Now, most people just think of division as the reverse of multiplication, and that's true, but it doesn't always help the child. So let's look at introducing division using the abacus. So first of all, what is it? Let's start out with a word problem here. Jacob has 12 flowers to plant. He wants to plant 4 in a row. How many rows can he plant? Well, let's start out by putting on 12 beads, and I want 4 in a row. So let's use take and give again until we get 4 in our rows. We're going to use take and give. Oh, we can do 3 rows. Oh, that wasn't so bad. That's what division is. Of course, we can write it as 12 divided by 4 equals 3. Let's do some division practice. This is coming out of level D. Oranges are packed with 6 in a bag. How many bags are needed for 48 oranges? Well, as we know, we're going to start out with 48. And I want to put them with 6 in a bag. So I'm going to use my take and give. And I'm get myself 6 rows here. Take and give. And there we go. So how many oranges will fit in my 6 bags? I can see that I have 8, which of course I can write as 48 divided by 6 equals 8. Now, some of you may wanted to approach this a different way, and some children do. Same problem, oranges are packed 6 in a bag. How many bags are needed for 48 oranges? So we start with our 48. And we use but I want to know how many, in each row I only want 6 because I have 6 in a bag. So I'm going to use the same take and give again. But this time I'm going to work myself down so I only have 6 in each row. So take and give, and I keep working it. Now somebody had commented, why can't you just do it in groups of 4? You could. And then maybe I'll end up with some groups of 2, some groups of 4. I like 2s, so it worked for me. Keep taking and giving until I get them all sorted out. My answer is, how many bags do I need? I need 8 bags with 6 oranges in each bag. Same equation, 48 divided by 6 equals 8. Remember how this looked when we did this on the multiplication table. We had 2 different ways of looking at it. We can look at it one way or the other way. And this brings me to an interesting point that Dr. Cotter wanted me to make sure I shared with you. When you're looking at division, and we're going to take a very simple one here. We say 6 divided by 2. The question is, how many 2's are in 6? So what we're saying is, I'm looking for the number of groups of 2's. So here's my groups of 2's. And how many groups do I have? I have 3 groups. Now I could say, again, how many 2's and 6? I could say, if I put these into 2 groups, how many are in each group? 3 are in each group. Both ways are accurate. And they're used at different places at different times, but there's 2 ways to look at it. And I realize there's a very subtle difference, but it's an important difference. In conclusion, why do we use the AL Abacus and use patterns? Because our brains are wired to think in pictures. And this provides the mental images for the future use. So a child can come up with their multiplication and the division, and they understand it. And it works very well, again, for children with learning challenges, because they are more visual than those without. That's why we want to use the abacus, to show our children how multiplication and division works, rather than just rote memorizing it. As we know, the abacus is what the whole RightStart Math program is built on. We have received awards for the RightStart Math curriculum. This particular one is from the Practical Homeschooling Reader Awards, where the readers will vote for their favorite programs. In 2014, we received first place, and in 2015, we received the first place award. We've also received from the old schoolhouse the Excellence in Education Award from 2014. We got the first place award. In conclusion, math needs to be taught so 95% is understood and only 5% is memorized. And Dr. Cotter says, our goal as teachers of mathematics is to help our children transform, expand, and refine these beginning ideas into deeper mathematical thinking. Any questions I can help anybody with? And I know you're a little bit handicapped because you will need to type out your question, but I will stay with you here until we make sure we have everybody's questions answered. And Susan, thank you. You are most welcome. I'm glad you enjoyed this. Well, again, thank you. Michelle's asking, is there a software version of this? No, there is not. And we probably, I take it back. There is, you can download an app from the Apple Store for both iPad and iPhone, and you can also get one for Android. It's the Abacus, but it's not an interactive one. It's one that you can work with yourself. So you can basically have an abacus on the go. As far as actually doing a software, like an interactive software, Michelle, no, we will never have that because we want the children to be touching something physical and working with you and having you lead their discoveries so that you're guiding their discovery as we go along. Another question here, just a second, right here. Carolyn says, will we be able to access a recording of this webinar? Yes. Once we get done with this, I am recording this. Once we get done with this, we go through, we clean it up, and then we will post it online. And I think we're about a week out right now. But yes, it will be available, Caroline. So you can certainly do that and share that with other people. Zoe says, I enjoyed your explanations. I missed the other meetings on Tuesday and Wednesday. Will they be recorded? Yes, they are recorded. And again, they will be on. Look for them in probably a week or two. We will try to let you know when those new ones get posted. Michelle is saying, I'm thinking of it for disabled students. Oh, that's interesting, Michelle. Great idea. What you could do, we have a very large abacus. We cleverly call it the AL Abacus Large. That is, the beads are 1 inch in diameter, so they are huge. So if you have a child with cerebral palsy or something of that sort, with some mobility, some dexterity issues, they can quite often move those themselves. So Michelle, if you would like to give us a call and talk to us, I'd be curious to kind of do some brainstorming with you to see what we can come up with that. I think that's a fantastic idea. Good. I look forward to your call, Michelle. Any other questions or comments? Well, thank you again, everybody, for your time. If you have any additional questions, please feel free to contact us and we will get an answer to you or talk with you and see what we can get done for you. Thank you, everybody. Have a fantastic day today.